Asphalt, also known as bitumen, is a sticky, black and highly viscous liquid or semi-solid form of petroleum. It may be found in natural deposits or may be a refined product. It is a substance classed as a pitch. Until the 20th century, the term asphaltum was also used. The word is derived from the ancient Greek sigma phi alpha lambda tau omicron sigma asphaltos. The primary use of asphalt bitumen is in road construction, where it is used as the glue or binder mixed with aggregate particles to create asphalt concrete. Its other main uses are for bituminous waterproofing products, including production of roofing felt and for sealing flat roofs. The terms asphalt and bitumen are often used interchangeably to mean both natural and manufactured forms of the substance. In American English, asphalt is the carefully refined residue from the distillation process of selected crude oils. Outside the United States, the product is often called bitumen. Geologists often prefer the term bitumen. Common usage often refers to various forms of asphalt bitumen as tar, such as at the La Brea tar pits. Another archaic term for asphalt bitumen is pitch. Naturally occurring asphalt bitumen is sometimes specified by the term crude bitumen. Its viscosity is similar to that of cold molasses, while the material obtained from the fractional distillation of crude oil boiling at 525 degrees Celsius is sometimes referred to as refined bitumen. Composition. The components of asphalt are classified into four classes of compounds. Saturates. Saturated hydrocarbons. The percent saturates correlates with softening point of the material. Naphthene aromatics, consisting of partially hydrogenated polycyclic aromatic compounds. Polar aromatics, consisting of high molecular weight phenols and carboxylic acids. Asphaltenes, consisting of high molecular weight phenols and heterocyclic compounds. The naphthene aromatics and polar aromatics are typically the majority components. Additionally, most natural bitumens contain organosulfur compounds, resulting in an overall sulfur content of up to 4%. Nickel and vanadium are found in the less than 10 ppm level, as is typical of some petroleum. The substance is soluble in carbon disulfide. It is commonly modeled as a colloid, with asphaltenes as the dispersed phase and maltenes as the continuous phase. And it is almost impossible to separate and identify all the different molecules of asphalt, because the number of molecules with different chemical structure is extremely large. Asphalt bitumen can sometimes be confused with coal tar, which is a visually similar black, thermoplastic material produced by the destructive distillation of coal. During the early and mid-20th century, when town gas was produced, coal tar was a readily available byproduct and extensively used as the binder for road aggregates. The addition of tar to macadam roads led to the word tarmac, which is now used in common parlance to refer to road-making materials. However, since the 1970s, when natural gas succeeded town gas, asphalt bitumen has completely overtaken the use of coal tar in these applications. Other examples of this confusion include the asphalt bitumen of the La Brea tar pits and the Canadian oil sands. Pitch is another term sometimes used at times to refer to asphalt bitumen, as in Pitch Lake. Occurrence. The great majority of asphalt used commercially is obtained from petroleum. Nonetheless, large amounts of asphalt occur in concentrated form in nature. Naturally occurring deposits of asphalt bitumen are formed from the remains of ancient, microscopic algae and other once living things. These remains were deposited in the mud on the bottom of the ocean or lake where the organisms lived. Natural deposits of asphalt bitumen include lakes such as the Pitch Lake in Trinidad and Tobago and Lake Bermudez in Venezuela. Natural seeps of asphalt bitumen occur in the La Brea tar pits and in the Dead Sea. The Athabasca tar sands are located in the McMurray Formation, Alberta. This formation is from the early Cretaceous, and is composed of numerous lenses of oil-bearing sand with up to 20% oil. Isotopic studies attributes the oil deposits to be about 110 mara old. Heavy oil or bitumen deposits also occur in the interbasin in Utah, U.S. The tar sand triangle deposit, for example, is roughly 6% bitumen. Asphalt bitumen occurs in hydrothermal veins. An example of this is within the interbasin of Utah, in the U.S., where there is a swarm of laterally and vertically extensive veins composed of a solid hydrocarbon termed gilsonite. These veins formed by the polymerization and solidification of hydrocarbons that were mobilized from the deeper oil shales of the Green River Formation during burial and diagenesis. Asphalt bitumen is similar to the organic matter in carbonaceous meteorites. However, detailed studies have shown these materials to be distinct. History. Ancient times. The use of asphalt bitumen for waterproofing and as an adhesive dates at least to the 5th millennium BC in the early Indus Valley. Sites like Mehrgarh, where it was used to line the baskets in which crops were gathered. In the ancient Middle East, the Sumerians used natural asphalt bitumen deposits for mortar between bricks and stones, to cement parts of carvings, such as eyes, into place, for ship caulking, and for waterproofing. The Greek historian Herodotus said hot asphalt bitumen was used as mortar in the walls of Babylon, a 1-kilometer tunnel beneath the river Euphrates at Babylon in the time of Queen Semiramis was reportedly constructed of burnt bricks covered with asphalt bitumen as a waterproofing agent. Asphalt bitumen was used by ancient Egyptians to embalm mummies. The Persian word for asphalt is mum, which is related to the English word mummy. The Egyptians' primary source of asphalt bitumen was the Dead Sea, which the Romans knew as Palus Asphaltites. Approximately 40 AD, Dioscorides described the Dead Sea material as Judaicum bitumen, and noted other places in the region where it could be found. The Sidon bitumen is thought to refer to asphalt bitumen found at Hasbaya. Pliny refers also to asphalt bitumen being found in Epirus. It was a valuable strategic resource, the object of the first known battle for a hydrocarbon deposit between the Seleucids and the Nabateans in 312 BC. In the ancient Far East, natural asphalt bitumen was slowly boiled to get rid of the higher fractions, leaving a thermoplastic material of higher molecular weight which when layered on objects became quite hard upon cooling. This was used to cover objects that needed waterproofing, such as scabbards and other items. Statuettes of household deities were also cast with this type of material in Japan, and probably also in China. In North America, archaeological recovery has indicated asphalt bitumen was sometimes used to adhere stone projectile points to wooden shafts. Early use in Europe 100 years after the fall of Constantinople in 1453. Pierre Bellon described in his work Observations in 1553 that pis asphalto, a mixture of pitch and bitumen, was used in Dubrovnik for tarring of ships from where it was exported to a marketplace in Venice where it could be bought by anyone. An 1838 edition of Mechanics magazine cites an early use of asphalt in France. A pamphlet dated 1621, by a certain Monsieur de Reynes, states that he had discovered the existence in large quantities in the vicinity of Neufchâtel, and that he proposed to use it in a variety of ways, principally in the construction of air-proof granaries, and in protecting, by means of the arches, the watercourses in the city of Paris from the intrusion of dirt and filth, which at that time made the water unusable. He expatiates also on the excellence of this material for forming level and durable terraces in palaces. The notion of forming such terraces in the streets not one likely to cross the brain of a Parisian of that generation, but it was generally neglected in France until the Revolution of 1830. Then, in the 1830s, there was a surge of interest, and asphalt became widely used for pavements, flat roofs, and the lining of cisterns. and in England, some use of it had been made of it for similar purposes. Its rise in Europe was a sudden phenomenon, after natural deposits were found in France at Osban, the Parc and the Puy de la Poy, although it could also be made artificially. One of the earliest uses in France was the laying of about 24,000 square yards of sessile asphalt at the Place de la Concorde in 1835. Photography and art. Asphalt bitumen was used in early photographic technology. In 1826 or 1827, it was used by French scientist Joseph Nice for NIE acute PCE to make the oldest surviving photograph from nature. The asphalt bitumen was thinly coated onto a pewter plate which was then exposed in a camera. Exposure to light hardened the asphalt bitumen and made it insoluble, so that when it was subsequently rinsed with a solvent only the sufficiently light-struck areas remained. Many hours of exposure in the camera were required, making asphalt bitumen impractical for ordinary photography. But from the 1850s to the 1920s it was in common use as a photoresist in the production of printing plates for various photomechanical printing processes. Asphalt bitumen was the nemesis of many artists during the 19th century. Although widely used for a time, it ultimately proved unstable for use in oil painting, especially when mixed with the most common dilutants, such as linseed oil, varnish and turpentine. Unless thoroughly diluted, asphalt bitumen never fully solidifies and will in time corrupt the other pigments with which it comes into contact. The use of asphalt bitumen as a glaze to set in shadow or mixed with other colors to render a darker tone resulted in the eventual deterioration of a good many paintings, those of Delacroix being just one notable example. Perhaps the most famous example of the destructiveness of asphalt bitumen is Teodor Géricault's Raft of the Medusa, where his use of asphalt bitumen caused the brilliant colors to degenerate into dark greens and blacks and the painting canvas to buckle. Early use in the United Kingdom. Among the earlier uses of asphalt bitumen in the United Kingdom was for etching. William Salmon's polygraphist provides a recipe for varnish used in etching, consisting of 3 ounces of virgin wax, 2 ounces of mastic, and 1 ounce of asphaltum. By the 5th edition in 1685, he had included more asphaltum recipes from other sources. The first British patent for the use of asphalt bitumen was Cassell's patent Asphalt or Bitumen in 1834. Then on 25 November 1837, Richard Tappan Claridge patented the use of sessile asphalt for use in asphalt pavement, having seen it employed in France and Belgium when visiting with Frederick Walter Sims, who worked with him on the introduction of asphalt to Britain. Dr. T. Lamb Phipson writes that his father, Samuel Ryland Phipson, a friend of Claridge, was also instrumental in introducing the asphalt to pavement. Indeed, mastic pavements had been previously employed at Vauxhall by a competitor of Claridge, but without success. In 1838, Claridge obtained patents in Scotland on 27 March, and Ireland on 23 April, and in 1851 extensions were sought for all 3 patents by the trustees of a company previously formed by Claridge. This was Claridge's Patent Asphalt Company, formed in 1838 for the purpose of introducing to Britain asphalt in its natural state from the mine at Pyrimont-Seyssel in France, and laid one of the first asphalt pavements in Whitehall. Trials were made of the pavement in 1838 on the footway in Whitehall, the stable at Knightsbridge Barracks, and subsequently on the space at the bottom of the steps leading from Waterloo Place to St. James Park. The formation in 1838 of Claridge's Patent Asphalt Company gave an enormous impetus to the development of a British asphalt industry. By the end of 1838, at least 2 other companies, Robinson's and the Basseterre Company, were in production. with asphalt being laid as paving at Brighton, Herne Bay, Canterbury, Kensington, the Strand, and a large floor area in Bunhill Row, while meantime Claridge's Whitehall paving continue in good order. In 1838 there was a flurry of entrepreneurial activity involving asphalt bitumen, which had uses beyond paving. For example, asphalt could also be used for flooring, damp-proofing in buildings, and for waterproofing of various types of pools and baths, with these latter themselves proliferating in the 19th century. On the London stock market, there were various claims as to the exclusivity of asphalt quality from France, Germany and England, and numerous patents were granted in France, with similar numbers of patent applications being denied in England due to their similarity to each other. In England, Claridge's was the type most used in the 1840s and 50s. In 1914, Claridge's company entered into a joint venture to produce tar-bound macadam, with materials manufactured through a subsidiary company called Clarmic Roads Limited. Two products resulted, namely Clarmic and Clarfalter, with the former being manufactured by Clarmic Roads and the latter by Claridge's patent Asphalt Co., although Clarmic was more widely used. However, the First World War impacted financially on the Clarmic Company, which entered into liquidation in 1915. The failure of Clarmic Roads Limited had a flow-on effect to Claridge's company, which was itself compulsorily wound up, ceasing operations in 1917. Having invested a substantial amount of funds into the new venture, both at the outset, and in a subsequent attempt to save the Clarmic Company. Early use in the United States. The first use of asphalt bitumen in the New World was by indigenous peoples. On the West Coast, as early as the 13th century, the Tongva, Louisiana and Chumash peoples collected the naturally occurring asphalt bitumen that seeped to the surface above underlying petroleum deposits. All three used the substance as an adhesive. It is found on many different artifacts of tools and ceremonial items. For example, it was used on rattles to adhere goods or turtle shells to rattle handles. It was also used in decorations. Small round shell beads were often set in asphaltum to provide decorations. It was used as a sealant on baskets to make them watertight for carrying water. Asphaltum was used also to seal the planks on ocean-going canoes. Roads in the U.S. have been paved with materials that include asphalt bitumen since at least 1870, when a street in front of the Newark, NJ City Hall was paved. In many cases, these early pavings were made from naturally occurring, bituminous rock, such as at Ritchie Mines in McFarland in Ritchie County, West Virginia from 1852 to 1873. In 1876, asphalt-based paving was used to pave Pennsylvania Avenue in Washington, D.C., in time for the celebration of the National Centennial. Asphalt bitumen was also used for flooring, paving and waterproofing of baths and swimming pools during the early 20th century. Following similar trends in Europe, modern use. Rolled asphalt concrete. The largest use of asphalt bitumen is for making asphalt concrete for road surfaces and accounts for approximately 85% of the asphalt consumed in the United States. Asphalt concrete pavement mixes are typically composed of 5% asphalt bitumen cement and 95% aggregates. Due to its highly viscous nature, asphalt bitumen cement must be heated so it can be mixed with the aggregates at the asphalt mixing facility. The temperature required varies depending upon characteristics of the asphalt bitumen and the aggregates, but warm mix asphalt technologies allow producers to reduce the temperature required. There are about 4,000 asphalt concrete mixing plants in the US, and a similar number in Europe. When maintenance is performed on asphalt pavements, such as milling to remove a worn or damaged surface, the removed material can be returned to a facility for processing into new pavement mixtures. The asphalt bitumen in the removed material can be reactivated and put back to use in new pavement mixes. According to industry surveys conducted annually by the Federal Highway Administration and the National Asphalt Pavement Association, more than 99% of the asphalt removed each year from road surfaces during widening and resurfacing projects is reused as part of new pavements, roadbeds, shoulders and embankments. Asphalt concrete paving is widely used in airports around the world. Due to the sturdiness and ability to be repaired quickly, it is widely used for runways dedicated to aircraft landing and taking off. Mastic asphalt. Mastic asphalt is a type of asphalt which differs from dense graded asphalt in that it has a higher asphalt bitumen content, usually around 7 to 10% of the whole aggregate mix, as opposed to rolled asphalt concrete, which has only around 5% added asphalt bitumen. This thermoplastic substance is widely used in the building industry for waterproofing flat roofs and tanking underground. Mastic asphalt is heated to a temperature of 210 degrees Celsius and is spread in layers to form an impervious barrier about 20 mm thick. Asphalt emulsion. A number of technologies allow asphalt bitumen to be mixed at much lower temperatures. These involve mixing with petroleum solvents to form cutbacks with reduced melting point, or mixtures with water to turn the asphalt bitumen into an emulsion. Asphalt emulsions contain up to 70% asphalt bitumen and typically less than 1.5% chemical additives. There are two main types of emulsions with different affinity for aggregates: cationic and anionic. Asphalt emulsions are used in a wide variety of applications. Chip seal involves spraying the road surface with asphalt emulsion followed by a layer of crushed rock, gravel or crushed slag. Slurry seal involves the creation of a mixture of asphalt emulsion and fine crushed aggregate that is spread on the surface of a road. Cold mixed asphalt can also be made from asphalt emulsion to create pavements similar to hot mixed asphalt. Several inches in depth, and asphalt emulsions are also blended into recycled hot mix asphalt to create low-cost pavements. Other uses: roofing shingles account for most of the remaining asphalt bitumen consumption. Other uses include cattle sprays, fence post treatments, and waterproofing for fabrics. Asphalt bitumen is used to make Japan black, a lacquer known especially for its use on iron and steel, and it is also used in paint and marker inks by some graffiti supply companies to increase the weather resistance and permanence of the paint or ink, and to make the color much darker. Asphalt bitumen is also used to seal some alkaline batteries during the manufacturing process.